Hello, everyone. This is session 2AB, and I just wanted to try something because we're actually playing a video for this. So I'm going to start the video, and if you don't hear it, could you type into the chat, please? So everyone in my cul-de-sac is now hearing this GSE session. So um, I am going to have to go on mute because it's playing back through, everything. So if anyone has any questions, please pop them into the chat and I'll try and answer them as we go. Right, thank you. Here we go for the whole thing. Drum roll.
Hello, my name is Tomáš Čech. I work in Broadcom company as a software engineer, and I would like to talk about Abend resolution in mainframe application using modern IDE or integrated development environment. First, let me mention the GSE UK conference charity raffle. The GSE UK region team hope that you find this presentation and others that follow useful and help to expand your knowledge of these systems. It's possible to donate to charities this year: Royal National Lifeboat Institution and Guide Dogs for the Blind. I would like to present an Abend resolution using a modern IDE, and for that purpose, I will be using Visual Studio Code, which is a very popular IDE. Because I will be using VS Code extensions, it's also possible to use other web IDEs that support VS Code extensions, like TIA or Eclipse Che. Bottom line of Abend resolution in VS Code is to empower next-gen mainframe users to manage and work with mainframe applications using modern tooling. For my use case, I will be using two VS Code applications, Abend Analyzer for mainframe and Debugger for mainframe, that are or will be part of Code4Z solution, which is the whole solution for mainframe users working with ZOS in modern mainframe IDE. Code4Z package contains other extensions like COBOL LSP for COBOL code development, high-level assembler language support for assembler code development, Zoe Explorer for interaction with mainframe datasets, USS files, and jobs, Explorer for Endeavor for interaction with CA Endeavor, and COBOL control flow for graphical visualization of COBOL program flow. Now I will show the real demo example. There are several ways how it's possible to resolve Abend in the application running on mainframe. I will be demonstrating the Abend resolution from VS Code on a COBOL file running in a batch application. I have open VS Code. From the marketplace, it's possible to install extensions Abend Analyzer for mainframe and Debug Editor and Debugger for mainframe. Debugger for mainframe is already part of Code4Z solution. For demonstration, let's assume the use case that we have a COBOL developer that is supposed to identify a root cause for a failing COBOL batch application. The developer receives information that a failing application produces Abend report that is stored in a given dataset. Assuming I am the developer, I will open Abend Analyzer extension in VS Code and add the dataset with the Abend report. Dataset is added. I will load the content. In order to display source code abending statement inside the report, there is a symbolic support feature. The symbolic support feature allows you to determine what statement the abend occurred on with all variables and their values. Symbolic support is provided through a file on the mainframe known as the prosim. This file contains information about your COBOL programs by post-processing the compile listing produced when your program is built. For my dataset, I provide the prosim. If there are a lot of reports, I can sort them and/or filter them. I can filter reports by several fields, for example, program, job name, user, Abend, and others. For my purpose, I will filter the reports by program, and in my case, the program name is Kamerkop. I can also sort the programs by the same fields. If I want to sort them by date, I can sort them ascending or descending. There is quick way from the right click from the context menu. Sort by day, for example, ascending. I know that my report I'm interested in was produced at the time of 1358. So I select the report, which starts downloading the report from mainframe and opens it in the main editor view. From the beginning, we see immediately a lot of useful information. For example, the abending code, what module failed. We can see the abending description, possible causes, and several strategies or suggestions how to correct it. We can see also abending statement from the failing source code. This information comes together with the variables from the statement line and the values of the variables. There is an option to provide in the report the lines before and after the abending statement so that the user has a more or knows better understands the context of the source code. We can see that more detailed information are provided within the report. In order to move inside the report, we can either use the scrolling or we can use the report tree on the left side in the tree view. So we can easily locate the required section. From the record, we can see, or from the report, we can see more information, like for example, module call sequence, more detailed information about the program, like when it was compiled, with the compile options, what symbolic information was retrieved from. You can see load library with leak options. You can also find in the report the memory maps. You can see open files at the point of Abend. You can see also safe area trace and execution options currently in effect when the report was produced. If we have application with more modules or more programs, we can see immediately from the report the failing program, failing module. And because as a COBOL developer, I want to understand better the program flow, I decide to debug it. For that purpose, I will use another VS Code extension called Debugger for Mainframe. First, I will set up debugging configuration in launch.json file where I specify what module I want to debug. Once I have debugging configuration ready, I start debugging. And this means that it will download the source code from mainframe and open it in the main editor view. And I'm able to debug the source code. As we can see, the program stopped at initial line. We call this line initial breakpoint, and it's the first statement of the debugging program. From here, we can step over or continue, or we can set up breakpoints. At first, I will set up the breakpoints. For example, I want to see the value of failing variable taskgram, but I don't want to stop the program at the breakpoint when running. For that purpose, there exists a special kind of breakpoint called logpoint that can display the message from the breakpoint line in the debug console. This message can include variables that are converted into values from that program line. So I will provide, for example, message tasknum equal, and in curly brackets, I provide the variable name. Now when I run continue, the program continues, and we can see that the program stopped at abending line. In the debug console, we can see also our logpoint message. Taskram equal value of the taskram variable. In this case, it shows us invalid format, which means that the variable wasn't initialized. Except that it also tells us the abending code, SOC7, that happened in the line 482. I want to know the value of the variable taskram in abending statement. On left side, I can see a list of variables with their values. I find variable taskram. I can see it has invalid format, which means it's not initialized. And that's the reason the application fails. So in order to fix this issue, the taskram variable needs to be initialized. To check the correctness of suggested fix, I can assign here the value to that variable during debugging. And now, because the variable is initialized with that value, and when I run continue, the program should continue and shouldn't be able or should let us pass the abending statement. I will add one more log point to check the value of variable task num. I hit continue, and we can see that the program passed the abending statement. It runs to the end successfully, and it shows us that the task num value from next line was incremented by 1 correctly. And that's all for our use case. So to summarize, I was showing how it's possible to work with an abending application on a mainframe in a modern development environment like VS Code through VS Code extensions that enable us to observe more detailed abending information with the possibility to debug an abending module. And that's all for my presentation. Thank you for your attention. You can submit your session feedback and check how to become a member of GSC UK. If there are any questions, I will be happy to answer them. Hello, my name
Okay, I'm back in the room. I hope you can hear me. Thank you very much, Thomas. That was excellent. Always good to see how ISPF isn't the only interaction method for modern COBOL or mainframe developer. So thank you for that. Does anyone want to ask any questions? I can unmute you in the event that you want to ask anything. If you wish to be unmuted, just pop something in the chat. I can do that. You should have been prompted to unmute, that's all.
Thanks, Stuart. So the question I had was that everything shown in the demonstration, is that available free of charge, or is there a license implication?
The extensions itself are free of charge. So if we talk about the extensions only, then yeah, these are free.
And at the back end?
At the back end, there are some licenses needed. But at this moment, I don't have the details about the licensing of the backend. So if you will be interested, yeah, I can check that and we can discuss it offline.
Great. Thanks very much. Thank you.
Yep.
Anyone else with questions? And please note the session 2AB. And actually, if I scrub this forward, I can probably get to the slide where Thomas has the feedback.
Submit your session
There we
feedback.
go. So all feedback is a gift. So if you don't mind completing the feedback on this excellent session, 2AB. So if there are no more questions, then I will close the session. So